All right, you are listening to the Maker's Quest podcast. I'm Brian Benham.
And I am Greg Porter. And it has been a little while since we've talked, Brian.
It
So we got a
has.
little catching up to do. I think tonight we're going to focus a little bit on maybe some of the projects that we've been doing around the shop and what's been keeping us so busy. And I will formally apologize to the audience for my voice. You'll hear it get better and get worse probably throughout the podcast. I'm on some medication. For those who don't know, I've been dealing with long COVID for just over a year now. And that has brought with it some lung issues that I have to use an inhaler for. And whatever steroids are in that inhaler just barbecue my vocal cords. So it's been kind of tough. Some days, Brian's called me and said, "Hey, do you want to record tonight?" And I'm like, "I can't even talk." So my voice, I sent Brian a text this morning or this afternoon and said, "I actually have a voice today. So this would be a great day to record." So hopefully we'll get through this without too much trouble, sounding like a young teenage boy with my voice cracking and stuff. But let's get into it. I know between now and the last time we spoke, you've made some deliveries on some projects that you've done and undoubtedly started some new ones. Can you share with the audience what projects you've wrapped up?
Yeah, so I don't think we've talked since I've come back from the final trip to Vegas for my Vegas project, but we got that thing all wrapped up. The chess table was one of the things that I think I showed you a render way back in like November, and then that kind of ebbed and flowed and got put on hold and got greenlit and then not greenlit and all kinds of things happened. But I finally got it built and delivered, and the client loved it. And I have to say that that was one of the hardest projects I have ever built as far as my patience in scribing things. So basically what it is a bonsai tree base that is holding up a chess table. So it's a root over rock vision. And so I had to scribe all these roots over this rock and have all 3 points line up at the same time. And if you've ever done any kind of scribe work, a lot of times, like you can cheat the back. Like if you're scribing to a fireplace, you can back bevel it because no one's going to see the back and then make sure it all fits nice and tight to the chimney or whatever you're scribing. But since this was going to be visible on all sides, I had no really good place to cheat it to the back. So it just took a long time. And there's a point halfway through where I was like, I don't know if if this is going to turn out well because I'm starting to stress out. Like, did I commit my skills? But in the end, it turned out pretty good.
Well, so for everybody's visual, how big is the playing surface on this chessboard, Brian?
It is the very top was 34 inches wide and 25 inches deep.
So maybe like a 1.5 of what you would normally envision as a chessboard scale. Is that relatively accurate?
Well, I don't know if there's a normal size chess table. Let me jump in my Google thing here and I'll pull up a picture I took at the job site.
Well, and while you're doing that, for those who may not follow Brian on Instagram, I think the photos were public of some of the root over rock process. I'm trying to remember if you sent those to me as direct messages or if they were public images.
A little bit of both.
A little bit of both.
Yeah.
Fascinating to see the level of detail that was required, uh, as Brian was describing, to scribe in a an amorphous, yeah, there you go, an amorphous root over an amorphous rock. When you sent me those, I thought, man, that is a great brain teaser.
Yeah. So the chess table itself, the client picked up in Mexico City, and so it sits on top of this glass mirror, and that's the mirror on down is what I built, and a different artist did the chess table up top. But
Wonderful. I asked that question about the scale of the chess board itself because I don't think I ever saw that. I think I the last I saw it was a table
yeah, I
with
don't
nothing
think
on
I've
top of it.
posted this image on Instagram yet.
Yeah. Oh,
But
that's
I should
super cool.
before we post this thing. There's the master bed for that same project. Let's see.
Yes.
So here's a good shot of all three sides here. So just scribing all the way around all those things just took forever. And then
There's
to get them all lined up was a little bit of a geometry issue because every time you set the trunk back to the rock, do you have it exactly lined up? And then you measure that angle and you're like, okay, and then you go to set it back again. Well, now the angle's a little bit off because you didn't, there's no real way to set it exactly back the way you always had it. So there was some extra scribing just to get the flats of the root and the flats of the trunk to line up.
Well, and we're focused on the rock and the roots, but you also had some joinery to get the limbs as they
Yeah,
are
the limbs and the
attached to the root system. So
yeah, and
an
those videos
insane
are on
amount.
Instagram.
Okay. I hope I'm not jumping ahead or any giving away any spoilers. Are you putting together a YouTube video of this build as well, or no?
Yes, eventually there will be a YouTube video. I am way behind on YouTube. I have like 8 projects I've recorded and have not had the time to edit them. I'm super far behind.
Well, it's a gorgeous table. Is that all walnut or is that a different species?
So the trunk and branches and roots are walnut, and then the base and the top that's holding the glass up is Wingay. And then there's little trays that pull out on either side, so you can like pull out a tray to set a glass of water on, but it's just a like I don't know if you remember back in the day, like you go to grandma's house and her cabinet had like a built-in cutting board that pulled out, and so just a
Yeah,
wood in a groove. That's basically the same kind of concept of that.
very cool. That is a killer project. Now, uh, the artist who did the chessboard, did he do the mirrored top, or is that something that you just got cut at a glass
Uh,
supplier?
yeah, the mirrored top, I just had the local glass company cut, but the silver base and then the copper and silver pieces and the glass that the chest is actually sitting on was from the artist in Mexico. And I have no idea who that person was.
Well, the whole thing is just a wonderful composition. Um, I mean, I look at both from a design standpoint and execution standpoint, just phenomenal stuff. That looked like a side table that went with your bed.
Yeah, this right here was just like a little vanity. Originally, they're going to put a mirror on top up here, so it's going to be like a dressing vanity. But when we went back on trip two, they had some pictures and things up there, so they decided not to do the mirror. But that is pretty common when working with clients that things change as you go.
Yeah, it's interesting, and I don't want to get too far off track, but as an artist, as a creative, as a designer, everybody thinks, well, I can just execute on my vision, right? My vision is the gospel. And I think really good design comes from a place where you're constantly taking your ideas and your thoughts and incorporating them with the needs and desires of a client. And that's what makes someone a custom furniture designer is that you can both understand and realize your vision as well as incorporate the vision of a client and perhaps another designer on board. I know you work a lot with an interior designer who's potentially an intermediary between you and the client, and maybe just sort of a third party sometimes, but sometimes in the middle there as well.
Yeah. Let me reshare my screen here. I wanted to turn off just in case I'm scrolling through my phone thing,
Yeah,
so I
yeah.
want to make sure I didn't share something I shouldn't have. But this drawer right here is a perfect example of your vision, right? So this drawer, the client wanted a soft close bloom drawer glide. And so this drawer right here is less than 12 inches. So the smallest Bloom drawer glide accommodates like a 10-inch drawer, but the actual hardware turned out to be 12 inches long. So I had to cut the hardware off to make it fit. And then the top to bottom is basically all hardware. So this drawer is very, very shallow. It's basically just a enough for like a remote control or something,
Uh-huh.
a TV remote. So yeah, so that's one of those things where like I was trying to size it for the hardware and the client was like, no, no, that's making the thing too big and too bulky. So here's the full piece. And so I wanted to make
Oh yeah.
this drawer deeper or taller to accommodate the hardware and then also have it more of a useful drawer. But she was like, no, no, that's it's this is the look I want. Nice thin drawer. And this is one of the things where like that old saying, form follows function. Well, she didn't really care about the function. She wanted the form. And that this drawer is more decorative than functional, which is fine. And then the TV cabinets above it. So
And it also follows the old adage of less is more.
less is more. Yeah.
That's definitely a negative space composition.
Yeah. And there's the TV cabinet above it. And so these shelves here, I wanted to do that same, mirror that same thing down here, but she was like, no, 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 because then that's too much.
Yeah,
So that's part of design, like listening and taking in other people's ideas. If you are just rigid on your own ideas, you're probably not going to end up with as cool of a design, or it'll be very boxed in design.
I love the balloon animal dog. I don't know what it is. That almost looks like it's a Day of the Dead theme.
Yeah, it very well be this client is a real estate developer, and for the last several years, they were building some big skyscraper in Mexico, and so they were living there. And
Oh yeah,
then that project concluded, and so then they moved back to the States. So yeah, they had all kinds of Hispanic and Mexican themed decor that we incorporated into the
incorporated.
design. Yeah.
Yeah, I kind of get distracted by cool things in the background
Yeah.
of
Yeah,
of
yeah. No, they had a
pictures.
lot of cool stuff like that in the house.
Yeah. Well, those are some pretty cool projects. I kind of couple questions. The chessboard. How long did you spend on the chessboard? I know everybody likes to know, how much do things cost and
Oh,
how long did it
how
take
long
you
did
to
it
build?
take?
But something like that, yeah, how long did that take you to put together?
Um, so I would say that that was probably 80 hours, and 40 hours of it was probably scribing the rock,
Uh,
or more than 40 hours of it. The rest of it, cutting the circle and building the little pullouts in the top, that was probably maybe 20 hours. So maybe probably 60 hours of time just scribing the rock and fitting the trunk and fiddling it. And then I decided to use a CNC machine to flatten off spaces 'cause that seemed like the easiest way to make a flat for the branches to connect to. And the CNC machine doesn't hold round things like that. So I had to build all these fixtures and clamp it, and I'll show that in the YouTube video when I get around to editing it. But yeah, I made all these kind of clamp things, and then instead of planning a tool path, because now I just have this fixture clamped in the middle of the table, and there's not really a place to reference. I just know that I want it to be in this one section. So basically, I used the CNC machine like a machinist mill. And I was like, okay, I'm going to set here. This is my zero, and I'm going to sweep across, and just kept sweeping across till I made my flat at this width and depth that I wanted. And that worked out pretty well. I did run into a bit of an issue with the software of CNC 12, or what is it, Centroid 12, or
Centroid, yeah.
whatever that is that Avid runs. Um, there's a safety mechanism in there that if you take too big of a bite while you're running the machine back and forth in manual mode, that it stops the bit and shuts down. So I had to take very, very light passes. So that's like super annoying because one of the things that I really liked about the Avid and having a vertical surface and all that was my thought was I was going to be able to use it like a machinist mill. And
Yeah.
now I got to figure out how to override that safety feature if I want to use it
I,
as a mill because it bogs down and shuts off. Or not that
wow.
it bogs down, but if it feels too much resistance, it shuts off.
Yeah. I don't. I don't know what a Mach 4 license costs, but I have a feeling Mach 4 will run on that machine. I I think it's fairly inexpensive. I want to say it's like $100 or something like that.
Yeah.
But Mach 4 will let you use the computer keyboard to go, kind of left, right, up, down, and then vertical with page up and page down. And it doesn't care what you do.
Yeah.
It will let you destroy your machine without stopping you.
Yeah. So, I
Uh,
mean, that's probably a good thing of this software, but like at the same time,
yeah.
it's one of those things that like I wasn't expecting that. I didn't realize it had that safety feature because where's that sensor at? How does it even know how much load happened just now? And I thought first I thought, well, maybe it's just because of a big bit, but then I used it in with just a 1/4 inch bit, and same thing, a little bit too much torque, and it shuts off, and I was
Oh, wow.
like
So the spindle must have some kind of a feedback that says, here's how much power I expect. Here's how many RPMs are actually coming out. When there's enough of a mismatch, it says, nope.
yeah. And the weird thing is when the machine is running, like you generate a tool path, and the machine is running and it's doing its thing, there's a log that shows all your stuff that's going on, all your code that's being sent. And whenever the machine bogs down, well, bogs down is not the right word because the machine doesn't ever really bog down. It keeps going. It gives no fucks at all. But um, but when it's under load,
Yeah.
right? When it gets under load on the screen that's showing you all the stuff, it'll show an error code that says something tripped, something overrode, whatever that error tripped.
Uh,
So like spindle sensor tripped, spindle sensor overrode. So when it's running, it knows to just override that to keep going. But if you're manually moving it, it's like, nah, you're not me. You don't get that power.
I can see, and I don't want to get off on an avid trip here for too long, but I can see Centroid is a commercial industrial piece of software. They use it to run, I don't know, I'm going to say hundreds of different CNC machines, but they use it to run a lot of industrial type CNC machines. And I can see where a manufacturer would want to program in a certain power load, maximum power load, because at some point you put a lot of stress on the electronics and wiring because your voltage drop uh, from being overloaded like that, and that's not really the right way to say it. You you have to overcome that resistance by more amperage, and
Hmm.
that's hard on things when you add more amps, and it can throw breakers and it can do all kinds of stuff. So I can see having that protection where it would shut it down before you would trip a breaker. Because if you trip a breaker, you lose your zero and your references and all that stuff. And in a production shop, that would be a long shutdown to get everything re-zeroed back out and set back up so you're cutting good parts again.
Right. And then especially if you had a big expensive sheet of something so yeah, so it makes sense that they would have it overrode, but like why in the manual mode? It doesn't let you do it. So
Yeah.
yeah, that's kind of frustrating thing. And then also they don't have a button to turn on and on the spindle. You helped me with that.
Yeah.
I texted you. I'm like, what the frick's going on here? How do I turn this thing on? And you're like, here, let me school you on G code. And so you got me
Yeah.
sorted out with that. But yeah, and that's like not to trash on Avid because I really do love the machine. But I emailed Avid and they're like, well, it's a safety thing. And I was like, well, how do I override? And they're like, well, we're not gonna they wouldn't tell me how to override it because I guess they probably didn't want the liability, but like
Yeah.
whatever.
Well, that, yeah, and that's the difference between their Centroid platform and their Mach 4 platform. Is Mach 4, there is a user base of millions of people that have all done custom programming for that interface. And if there's anything that you need to make it do, there's somebody who's already tried. and they can tell you exactly. Yeah,
how to
you could
do
just
it. Yeah.
quick internet search, and all of a sudden you have the keys to the castle, which can be dangerous. You can drive that machine right through the spoil board if you're not careful with some of that
Yeah,
automation
that's
stuff.
another thing that I got caught up on. So I got the vertical work holding surface, right? So you can plunge below the depth of the spoil board, but there was a setting in there that doesn't allow you to plunge it to protect your spoil board.
Right.
And so it rendered the vertical work holding thing. If I wanted to cut a deep mortise in there, it wouldn't do it until I found that one you are allowed to override. So I did was able to turn that off. But yeah, it's just like all the safety features, like whatever happened to the good old days where you could just turn it on and hope not to die.
I go back to I've probably told this story on our podcast before, but when I was out at the Autodesk Build Space, I was using their Tormach for the first time, and the Tormach there was sort of the Wild West. They didn't have tool numbers, they didn't have a tool library, they didn't have anything. It was just whoever showed up to that machine that day got to override everybody else's settings. And I was getting ready to cut my first part, and the first operation was a facing operation with a 2 inch wide shear hog, is the name of the tool. And whoever had set that tool up didn't use the right offsets. And the tool in the machine thought it was about an inch and a half shorter than it was. And thank God, the facing operation, I gave it like 4 inches on either side of the workpiece to come down and kind of work into the workpiece. And it was going full speed. I mean, just ready to lay waste to something. And it was down like half an inch below the top of the vise. So this 2 inch shear hog almost went straight into a 6 inch vise. It's like, oh my God, hit the red button, stop it, empty your pants, start over.
Yeah,
But but yeah, sometimes having those safety features is a good thing. Um, I know for a fact that day on the Tormach, I kind of wished that they had a few of those things set up. But anyway, I
for sure.
digress.
Yeah, I've definitely had a few destructive moments where the machine just kept going. I was like, oh, ripped
Yeah,
my fence off that I had my little fixture off there like it was nothing.
the uh, the escape key. It always seems like it's another inch away from where it needs to be when that happens.
Yeah.
Like,
Well, I've gotten into the habit when I'm running a tool path for the first time, especially one that could be potentially a little sketchy, where I'm like, I'm not really sure if I got it right, to have that puck in my hands, so I can whack it.
yeah, yeah. I know on mock, if you hit the red emergency stop button, it's a bad thing because it loses its place in line. It loses its XYZ.
Oh yeah.
And if you hit feed hold, it doesn't lose that. So that's the magic. I always have the mouse in my hand and the clicker on feed hold, and then I run everything at like 25% of normal speed until I'm comfortable. And and that has saved me so many times I can't even count. Some of it, definitely user error, other things. It's like, what is this machine doing today? And
Yeah, that's one thing I miss on my little hobby machine. It had a pause and it would pause the feed and turn the router
yep.
off. In Centroid, you can pause the feed, but it keeps the router going.
Mm,
So I'm like, if I don't want to leave it unattended and I need to go to like the bathroom or something, I just want to pause it. The router's still running. I'm sure I could use the MIDI G code to slow the router down or turn it off and then turn it
mhm.
back on, then resume my feed. But that's a lot of things I think it should just be in a singular button. Like you hit it
Wow.
and it pauses everything.
Yeah. Well, and we discussed that uh, the mock user interface has a router on, router off button. So at any time, just without G code running or whatever, if you want to turn the router on, you can turn it on.
Yeah.
Um, and which, you know, good, bad, or indifferent, those controls are always there, which it is. It's kind of nice. Um, yeah.
Yeah. So yeah, so I mean I got a bazillion things going on we could talk about, but like what do you have going on in your skyscraper garage these days?
I was going to say everything that I've got going on right now is guitar related. Hopefully that doesn't get too boring for everybody. But one of the things I'm probably most excited about, I think I've mentioned on this podcast before that I sell side benders. So if somebody's going to build an acoustic guitar and they want to bend the sides, I sell a machine to do that. And uh, the machine design is based loosely around an older design that a company that went out of business a couple years ago did. And it, my desire was to make it backwards compatible. So if somebody had bought one of those machines prior, they could use my forms and they could, upgrade and kind of do that and keep their old machine alive, and out of the junkyard, so to speak. And one of the things that the old company that went out of business is called LMI, Luthier's Mercantile International, I think. Um, One of the things that they didn't offer is if you had a guitar with a cutaway, which this acoustic guitar back here has one. So, like this little piece right here, this piece is really easy to bend, just kind of two humps. But you put a cutaway in there and it uh, gets a lot more involved and interesting, let's say, because the bends are much tighter, and it's just a different animal. And I had put together when I started making those machines, I had put together kind of my first stab at forming those cutaways, and I never really liked it. Um, it worked. It's hard. It's clunky, uh, but it produced results. So I sold them, and I've sold a few handfuls of them, but really kind of discouraged people from buying them unless they were like, yeah, this is exactly what I need. And in the back of my head, I've been working on, okay, how do you make this how do you make a cutaway uh, machine or form that works like you would want it to? And so that's been stewing in the back of my head for like 2 years. And I don't know, 6 weeks ago, I woke up on a Saturday morning and I said, you know what? I'm going to solve this problem and I'm going to solve it right now. And I got out my sketchbook and I started drawing things. And I basically told myself, you're not going to get up until you have a viable solution for this that you are going to be happy to sell and you're going to be excited to sell and people are going to be excited to use it. And probably 3 hours later, I sketched up something that I was like, this is going to work really well. And it will also work for everybody who bought my first version of the cutaway bender so that they can retrofit it into their system without having to buy a whole other set of forms for their cutaways. And I've worked through 4 prototypes now. And it gets pretty persnickety, right? Like, exactly what bolt length do you need for exactly this thing, and how do you get clearance around X, Y, and Z? And it involves some like big 1/2 inch roll pins, which I didn't even know they sold. And when I found them, I was like, this is the piece that's going to make this thing actually work. There's sort of the design that you have. And when you start putting, putting the dollars to it, every custom part that you have to machine costs a fair amount of money. So the more stuff you can find already made out of the catalog, you can bring that price down very rapidly.
Hmm.
And so there was a couple pins and shoulder bolts and like I said, roll pins that that I finally got to a point where it's like, okay, here's all the components that have to work together to make this work. Well, now you have an overall width and clearances and things like that. So I'm down to kind of the final bolt sizing that I need to do to get all the hardware to fit this thing for it to operate smoothly. So it's going to work. I don't know if you know what a veneer press is. It's just basically an Acme thread with a handle on top and a threaded piece, but it's a ram that works with a veneer press set of hardware, plus one custom machine piece that we're going to do. And then that RAM is kind of removable. And then there's another piece that's the form. But the big difference on that, and I hope I'm not nerding out here too much for people, but everybody else who's done a cutaway ram, it's been a very linear thing, right? It comes in with a form and it just kind of pushes on the wood. So the wood is able, because you have these really tight bends, the wood is able to kind of move in both directions away from this ram. There's no way to capture it at one end and kind of work it toward the other. The design that I did hinges where that bend starts and slowly comes down from one direction. So instead of ramming it from the center, so to speak, so everything could work outwards, it starts at one end and it kind of linearly uh, bends it down into the form so it captures it as it goes, so it can't sneak out the other end. And it's the only one that'll be on the market that has that feature.
So it kind of
And
wraps it around the form instead of presses like this is going to just wrapping it around.
yeah, exactly. And I mean, you can do it any way you want, but being able to capture that end so that you get a very repeatable result every time kind of was my desire. And again, there's other people who have cutaway rams for side bending forms and things, but nobody has a hinge design like what I have, which I'm not bragging that I'm the smartest guy in the world. I just think it's a better way to skin that cat. And if you're there are kind of two groups of people who make acoustic guitars. Um, there are the people who just want to make one for their friend or make one for themselves or make, a handful of them for their family. They don't take it too serious. They do it as a hobby, whatever. And the other group is the people who make 30 and $40,000 custom acoustic guitars that, you know, their business is you make or break it on the quality of your instrument. And so they want this very repeatable, predictable process for bending sides or doing anything that they're doing, cutting braces or assembling, bodies of guitars or necks or what have you. And so it was kind of done with that level of craftsman in mind, somebody who had kind of gotten past the is it going to be close? Yeah. Is it going to be right on the money? Probably not. You know, that whole roll of the dice, the people who've kind of gotten past there. But then the other piece of that is I have what they call outside forms or outside molds that once you bend your sides, you can imagine they're hot and you've just deformed a piece of wood that's been in the same orientation for the last 100 years. It wants to go back to being a straight piece of wood now.
Hmm.
And you take them out of the bender and they're usually still warm, and so they have that ability to kind of spring back and stay back instead of stay where you want them. And so I have a whole series of outside forms that go with those. And there's a plug in there for cutaways. And that plug is the exact same shape, of course, as the bending molds and everything else. So um, as you're making these sides, you can very quickly take them off the bender, put them into the mold, put stretchers in the middle of it so that you can let it cool for a week if you want to before you work on it again. And when you come back to it, it's going to be that exact shape that you want that
It'll
fits
hold
the
its shape.
template. Yeah. And so everything has a set of templates, a set of bending molds, and a set of outside forms. They all go together to kind of make the guitar. Um, and so that's been that whole thing has been in the works for about 2 years now, and kind of being that close to the end of the foot race has been very exciting. So I'm hoping here in the next week or two I'll have that ready to go retail. There's still a few tweaks, like I said, in terms of hardware that I need to work out, but all the preliminary tests I did were just fantastic. And then I've I've also got along that same vein. Um, I'm not sharing any like industry secrets here, but when you bend wood, anybody who's ever bent wood, the first attempt that you have at it, you usually screw up whatever you're trying to bend, because you don't know the limitations of the material, and you don't know um, how
How
what do I
far you
want to
can
say?
go before it breaks. That's what
Yeah,
I've,
yeah.
how tight of
How
a radius.
how small of a radius? That's what I'm trying to say. How tight you can make that bend before it starts to break. We all find those things out. But by the same token, as guitar builders, you have target dimensions. No matter what kind of wood you're using, you have the same target dimension. Well, the properties of a rosewood versus a wenge versus a walnut versus a maple are very, very, very different in terms of what they'll tolerate in the bender. And some of the sets of sides that people bend can range from, call it on the low end, $50 for a set of sides to bend, up to several $1,000s. And when you're doing some of those tight radius bends, and you're bending a set that cost you a few $1,000s, um, the sphincter factor is pretty high. And one of the things I'm going to share on my YouTube channel, there's a guitar builder named Ken Parker, who's a pretty famous guy. He had Parker guitars back in the 80s. He designed a guitar called the Fly, that was, it's like the Edsel, right? It was so far ahead of its time that nobody wanted it, right? It was at a time when everybody wanted these pointy shaped guitars because it was heavy metal and it looked cool, versus the Fly was this really sleek design that was very minimalistic, but just phenomenal on every level. And a lot of people bought them, but a lot of people rejected them because it wasn't flashy and polka dotted, right? And but Ken is an incredibly intelligent luthier and builder, and now he builds uh, hollow body's not the right word, but it's a hollow body style guitar called an arch top, and they use them a lot in jazz musicians use them a lot, and they're very high dollar guitars, very sought after. And he has a whole series that he did on how to bend these intricate sides without breaking them, and part of that process was using linen and epoxy. And essentially, again, anybody who's bent wood knows that the outside of the bend is where the wood is going to fracture. It never fractures on the inside of the bend. And if you study strengths of material and how that works, there's a compression side and there's a tension side, right? And that tension side is what blows out. You get too much tension in those fibers and they can't stay connected anymore, right? But on the compression side, you can push wood together forever and it won't separate. Not forever, but you can put a lot of compression into a piece of wood before it'll separate. Well, Ken realized that if you use epoxy and linen on the tension side of a bend, the epoxy and the linen take all the tension and they push the outside face of the wood more toward the compression side so that you don't get splintered out. Well, the difficult part of that is you now have to remove that epoxy and that linen from your finished face of your guitar. And it's a process. It's not like overly difficult, but it involves a lot of heat and scrapers and elbow grease. There is a tape out there called Captain tape, and it's used in powder coating to mask off different types of things. And it's a high strength tape that can endure like 1,000 degrees before the adhesive starts to delaminate. And I discovered that that will hold up to the 350 degrees you need to bend a guitar side. And if you use that Captain tape to um, kind of laminate to the outside of your pieces that you're going to bend, they won't splinter out no matter how tight that, well, not no matter how tight that radius is, but you can get away with a thicker side and a tighter radius simply by using that type of high temperature tape on the outside of the guitar. And then instead of having to scrape it off and everything else, when you're done, you just peel it off.
Right.
So I'm gonna put together a demonstration when I get this whole cutaway form done and the ram done that shows, if you're going to do this and you're really you've got a high dollar set of wood or you haven't got a lot of experience, this is the way to go about it without having a bad day.
Yeah. Okay. So you said that tape was typically used in like powder coating.
Yeah,
Interesting. So now on the epoxy version of that, do you epoxy that, put the linen in, and let it dry in its flat state, and then heat that whole thing up?
that's correct.
So you have to heat the epoxy and bend the epoxy with it.
Yeah. And different epoxies that I mean that's one of the, if anybody wants to see a great series on YouTube, Ken Parker's Arch Toppery is a master class in guitar building, um, guitar technology, historic guitar technology, all the way back to the lutes made out of gourds. He gets so deep into the history of how instruments have been made and the materials. So it starts back at gourd lutes and works its way up to the most contemporary guitars. So and he it ends. Ken's experiments end with carbon fiber composite necks and things of that nature. Like it goes beyond what most manufacturers are doing today. But he gets so deep into the why, the how, and all of those things. But one of the things that he spends a fair amount of time on, and this is an ongoing series. So he's not done with it, but he's in the middle of it somewhere, probably 30 episodes deep. And he talks an awful lot about different epoxies and the different properties of different types of epoxies, where one is appropriate and a different one might be appropriate in different situations. And part of that is the temperature resistance of that epoxy before it starts to delaminate. So if you're bending sides, you have to pick an epoxy that will withstand the type of heat that you're going to use.
But this
Um,
this tape will alleviate the need for epoxy, and you can just bend it. So now, like this is different than steam bending, right? Like steam,
it's different, but it's the same.
same.
So part of what you do, kind of the modern way of bending things, and different people have different ways of doing it. But the modern way of bending things is you take the piece that you're going to bend, you don't soak it in water, you spritz it. So um, the steam, the steam is a vehicle for heat. The water itself doesn't help you bend wood. The
Doesn't
steam is a
soften the fibers or anything like that.
It doesn't. The heat of the resins inside of the glue is what's important. The steam is a very fast carrier for heat, which is why people steam bend, because the steam can penetrate through the wood very, very fast. Where if you just put it in an oven, you're more likely to burn your wood before you get it to where it wants to bend, because it's not going to be a, a through and through type of saturation of heat.
Okay.
Um, so you spritz it down with water, you encapsulate it in aluminum foil so that you get, I think you would call it like osmotic, right? Like the steam goes through, condenses, and goes back through. But then you use heating blankets as a heat source. So you have this piece of wood wrapped in aluminum with water inside of it, and then a heating blanket sitting on top of it that's going to heat it past the steam point, or the boiling point for wood, right? So that gets the wood pliable. Um, and then you put it in your bending machine and you press down the waste and you do all the other things you're going to do. And the hope is that you let it cool off enough that it retains quite a bit of its shape, and then you immediately put it into an outside mold. But that the Kaftan tape can hold up both to the moisture I found, which actually surprised me when I found that out. I thought, oh wow, this is a keeper. Like I think
Hmm.
I'm on to something here. But then it can also hold up to the heat. And surprisingly enough, when you're done, it peels off with very little effort. Like I thought,
So, so in
man,
essence, you're still kind of steam bending it since you're putting
y-
water in there.
you absolutely are.
Okay. And the steam is just a carrier to get the heat to the wood. So there's a lot of people on YouTube that have these videos where they soak their part in water and like fabric softener. So
Yeah.
you're saying that's all BS.
No, I'm not saying that's BS. If you were to take a piece of wood with no water on it, right,
Hmm.
and try and bend that, you're going to have very little success. No heat, no water.
Okay.
Take a piece of wood and stick it in water, you're going to have more success than with no heat and no water. Take a piece, stick it in water, get that water to a boiling point, you're going to have more success. Take it out of the water, put it into a chamber where there's water under it and heat around it, where that water turns to steam, and you're going to have more success. One step further is where I'm at, saying if you wrap it, put water on it, wrap it, heat it to the boiling point, you're going to have even more success. And it's a very fast process. So when we fire the heating blanket up, it's ready to bend in under a minute.
And this heating blanket is like a special heating blanket. It's not like a blanket off your bed. It's a special blanket for steam bending or
Correct.
bending
So,
wood.
so we have hang on. Oh, I have some of the heating blankets behind me, but we have a temperature controller, and your heating blanket plugs in here, and you can control that. It has a thermocouple type sensor, and that goes between. Well, you can put it anywhere you want, but I suggest to people that they put it between the heating blanket and their wood, and that lets you know the temperature that it's getting to. And somewhere around the 320 to 360 degree range is pretty good. Um, and that heating blanket gets up to temperature very quickly, a minute or two, and then it takes a little bit for the wood to saturate through, but you can actually hear out of the ends of the aluminum foil, you can hear the steam escaping. So it's kind of a cool it's kind of a cool process. It is a timed event because at some point enough steam escapes that the wood starts to dry,
And
right?
then becomes brittle.
Yeah, and really, like I said, it's not the steam that is the bending agent, it's the heat. But when all the water evaporates, the heat becomes very uneven. That's the issue. So you have to work quickly. Back to the fabric softener. There is some magic to the fabric softener that helps break down the resin. Where I get a little bit wiggly is if you're breaking down the chemical composition of the wood. That resin is what sticks the fibers together, and if you heat that resin up and you let that resin cool in place, it's going to have the same strength that it did before you heated it, right? That heat cycle is not going to ruin the resin. If you start introducing chemicals, I have not done enough study to say the chemicals affect it adversely or they don't affect it adversely, but I've got to think the reason the fabric softener works is the same reason it works on textiles, is it starts to break down the fiber to where the fiber is softer, right? I mean, it's the same thing when you wrinkle up a piece of paper 1,000 times and it gets really soft.
Hmm.
It's not, well, it's because you have broken those long strands of fibers in the paper. And when I say long strands, it's microscopically long, but when you wrinkle it up 1,000 times, they become microscopically smaller. um, but that's how it works on your shirt, right? Like the reason your
Right.
shirt's stiff is because those fibers are stiff, and those fabric softeners go and break down the fiber. So I would have to think that if you're putting that on your wood before you bend it, that it's not breaking down the resin so much, but it may be breaking down the bond between the resin and the fiber, but I think it's probably breaking the fiber itself down and probably making it a little fuzzier. I don't know that, but in a guitar, you're looking for that strength to weight ratio. That's the magic thing, is you want it to be as thin as possible, but as strong as possible. And anything you do that might threaten that,
Is
uh,
bad news.
I feel
So
like
in
leads you down. But there
yes,
are also some commercial bending agents as well. I would assume they work in much the same fashion.
yeah, like I'm following your theory, and it totally makes sense that it's got to be breaking something down if it's going to actually make it softer. So you could potentially have bigger spring back or more spring back when it cools if that resin and fiber don't harden back up as rigid as it was. And then also
Yeah,
I
and
wonder if like that's going to cause problems with glue. Like, is your glue going to stick to this thing that's now saturated with downy or
right.
whatever fiber that is?
Yeah, and when you look at specifically in the acoustic guitar world, there are certain species of woods that are very sought after. Brazilian rosewood is number one, and you can't buy Brazilian rosewood anymore legally unless it was imported prior to the CITES ban on export and import of that species. Um, so that said, the reason it is so sought after, I don't know how much rosewood you've ever run through your drum sander, and it doesn't have to be Brazilian, it can be any kind of
Oh,
rosewood.
well, then quite a bit.
Yeah. So the rosewoods that you run through your drum sander, the resin will just clog your paper up in a very, very,
Hmm.
very short amount of time. And most of the very sought after ebonies, things of that nature that are considered, the sought after tone woods are very resin heavy woods. They're very brittle, crystalline type type structures, as is how I describe them. Um, when you hit them with your finger, they click back at you rather than thump, and that's what makes them resonant, and that's what makes a guitar good. So anything you do to affect that resin to wood bond negatively is a bad thing for a guitar maker. They want that thing to be as resonant and I say brittle as possible. Different guitar makers want different effects, but by and large, the body of a guitar, you want it to be very stiff, very thin, um, and very resonant. So yeah, so the Downy trick, nah, I don't know. I'm sure it's probably fine, especially in fine woodworking, right? You're not judging a table based on the tone of that table when your knee hits it.
Right.
Very different ball game,
When you
right?
set your
Um,
spoon down on the dining table, you want a nice resonance.
yeah. Although there is something to that, but um, so yeah, so that's probably that was really long-winded, but that's
Mhm.
that's what I've been working on a lot in my shop. The other thing that I have been doing is I've got one next to me here, and I'll just kind of add. I've been building this guitar. It's a Indian rosewood and spruce guitar. Um, and I've been building that with a guitar builder that's here in Parker, Colorado, that I've wanted to build a guitar with for a very long time. And I've been spraying finish on it here for the last, gosh, when was the date here? Oh, May the 4th. That's right. May the 4th be with you. Star
Yeah.
Wars Day was the day that I last sprayed finish on this. So it's finally hard enough that I'm gonna finish sand and polish it, and then we'll be ready to. We've got about another half a day worth of work to put the bridge on it, get strings on it, tuners in it, and all that kind of stuff, and we'll be done. So um, that's been my passion project that I've been doing kind of on the side.
All right.
But I'm looking at the clock, Brian. We didn't get through very many projects, kind of like one a piece.
Yeah. That's all
and,
right.
and we're an hour in, but I think there was a lot of additional information about other projects in there,
Yeah.
and hopefully some good nuggets for our listeners.
Yeah, for sure. So you want to take us out?
I am Greg Porter. You can find me at SkyScraper Guitars and Greg's Garage, both on Instagram and YouTube.
I'm Brian Benham. You can find me all over the web looking for Benham Design, and you're listening to the Maker's Quest podcast. Thanks for listening.